Hello everyone, welcome to the session on operating systems, unit 2 process management. In today's session we are going to discuss an important topic, communication in client server system. Modern computer system, different processes often need to communicate with each other. This communication becomes especially important when the processes are running on different computers connected through a network. So in this session, we are going to understand what a client server system is, how communication takes place, and the different mechanisms used for communication. Major communication mechanisms that we will discuss are sockets, remote procedure calls, RP or RPC, pipes, and remote method invocation or RMA. Now let us understand what is a client server system. A client server system is a computing model in which two types of programs work together. They are the client and the server. The client is a program that requests a service or information. A server is a program that receives the request, processes the request, and provides the required service or information. Let us take a very simple example. Suppose you open a website using Google Chrome. In this situation, your web browser acts as the client. The web server hosting the website acts as the server. The browser sends a request and the web server processes that request and sends the required web page back to the browser. So we can remember the basic communication as client sends a request, server processes the request, and server sends a response. This simple request response model is the foundation of many network applications. Now let us look at the diagram. On the left hand side we have a client, on the right hand side we have the server. Between them we have the network. The client requests a service from the server. This request travels through the network and reaches the server. The server receives the request, processes it, and sends the responses back through the network. So, if you look at the arrows in the diagram, the green arrow represents a request moving from client to server, and the blue arrow represents the response moving from the server back to the client. For example, when you enter a website address in your browser, the browser sends a request to the web server. The server processes the request and returns the web page. So the complete sequence is request, processing, and response. Now the next question is, how can the client and server communicate with each other? There are different mechanisms available for communication. In this presentation, we are going to study four important mechanisms. The first one is sockets, the second one is remote procedure call or RPC, and the third one is pipes, and the fourth one is remote method invocation or RMI, which is commonly associated with the Java. Each mechanism provides a different way for processes to exchange information. Sockets are commonly used for network communication. RPC allows a process to call a procedure running on another system. Pipes provide a stream-based communication mechanism between processes. And RMI extends the remote communication concept to objects in Java. Let us now study these mechanisms one by one. The socket is defined as an endpoint for communication. In simple words, we can think of a socket as a communication point through which one process can communicate with another process. A socket is associated with an IP address and port number. For example, the presentation gives the socket 161.21.19.8:1625. This means the host has the IP address 161.25.19.8 and the communication is taking place through port number 1625. So the IP address identifies the host or computer The port number helps identify the particular network service running on that host. So the IP address plus port number together identify a socket endpoint. The slide also mentioned that communication takes place between a pair of sockets. That means one socket belongs to one communication endpoint and another socket belongs to the other endpoint. There are well-known port numbers. Ports below 1024 are traditionally associated with standard services. Another special IP address is 127.0.1. 127.0.0.1. This is called the loopback address. It refers to the system on which the process is running. So, a process can use loopback address communicate with another process on the same issue. Now let us understand this circuit diagram. On the left hand side we have the host X. Its IP address is 146.86.5.20. The socket on this host is 146.86.5.20:1625. On the right hand side we have the web server. Its IP address is 161.25.19.8. The socket used by the web server is 161.25.19.8:80. Now the important point is the communication occurs between these two socket endpoints. So we have client socket communicating with the server socket. Port number 80 is commonly associated with the web services. Therefore, when the client wants to communicate with the web server, it needs to identify the server using its network address and the appropriate port. This is a basic idea behind socket-based client-server communication. Now let us move to the second communication mechanism, remote procedural call or RPC. RPC provides a way to communicate between processes running on networked systems. The important idea behind RPC is it allows a process to call a procedure that is actually executed on another system. Normally, when we call a procedure, the procedure executes on the same machine. But with the RPC, the procedure can execute on a remote machine. The communication mechanism hides many of the networking details from the programmer. RPC uses stubs. The client-side stubs act like a proxy for the actual procedure running on the server. The client calls the client-side stub. The stub locates the server and prepares the parameter for transmission. This process is called marshalling. The message travels through the network and reaches the server-side stub. The server-side stub receives the message, unpacks the parameter, and performs the required procedure on the server. After execution, the result is returned to the client. So the basic flow is client-side stub, network, server stub, server procedure. And then result travels back to the client. Now let us look at the diagram. Suppose the client wants to call a procedure, for example P of x, y, z. The client makes the procedure call. The client side stub converts the procedure parameters into suitable message format. This is called marshalling. The message is then sent across the network. At the server side, the server stub receives the message, it unpacks or unmarshals the parameters. Then the actual procedure is executed on the server. Finally, the result is returned to the client. There are some important issues in this communication, different computer architecture may represent data differently. For example, we have a big Indian and a little Indian systems. Therefore, data representation becomes important in remote communication. It refers to an external data representation format for handling differences between architectures. Another important point is remote communication has more possibilities for failure than local communication. For example, the network connection may fail, the server become unavailable, or a message may be delayed. Therefore, RPC system needs to consider these additional failure situations. The operating system or RPC system may also provide a render-swiss or matchmaker service to help connect the client with the correct server. Now let us move to the third communication mechanism, pipes. A pipe is an inter-process communication mechanism which allows data to be passed between processes. A pipe can be viewed as a stream of data. The data is generally transferred in a first in, first out or FIFO manner. That means the data that enters the pipe first is normally read first. Here it is shown two important types of pipes. The first one is ordinary pipes. The second one is named pipe. The ordinary pipe is normally associated with the processes that have a parent-child relationship. For example, a parent process can create a pipe and then create a child process. The parent and child can use the pipe to exchange data. Named pipes are more flexible. They can be used even when the communicating processes do not have the parent-child relationship. So, named pipes provide more flexible mechanism for communication. Now let us look at some practical use cases of pipes. The first example is shell comments. A very common example is ls pipe grep.txt. Here the output generated by the ls command is passed to the grep command through a pipe. The second example is parent-child process communication. A parent process can create a pipe and then create a child process. The two processes can communicate through the pipe. Third example is producer-consumer problem. Here one process acts as the producer. It writes the data into the pipe. The another process acts as the consumer. It reads the data from the pipe. The fourth example is client-server communication using named pipes. A server process can create a named pipe. A client process can connect to this pipe to send requests or receive responses. So pipes can be useful in several practical IPC scenarios. Now let us compare ordinary pipes and named pipes. First, ordinary pipes normally follow the producer-consumer model. The producer writes the data to the write end, and the consumer reads data from the read end. Therefore, ordinary pipes are generally unidirectional. The communication flows in one direction. It also points out that ordinary pipes generally require a parent-child relationship between the communication processes. In Windows system, there are also called anonymous pipes. Now let us look at the named pipe. Named pipes are more powerful than ordinary pipes. They can support bidirectional communication. Also, a parent-child relationship is not necessary. Several processes can use a named pipe for communication. Here is an example, mkfifo space mypipe. This command can be used to create a named pipe in Unix-like system. So remember the main differences. Ordinary pipe generally unidirectional and parent-child based. named pipe more flexible and can be used between unrelated processes. Now let us move to the fourth mechanism, remote method invocation or RMI. RMI is a Java mechanism that allows an object running in one Java virtual machine or JVM to invoke a method on an object located in another JVM. The other JVM may be running on the same physical machine or on a different machine connected through network. RMI extends the idea of remote procedure call to the world of object-oriented programming. In RPC, we generally think in terms of procedures or functions. In RMI, we think in terms of objects and methods. So, a client can invoke a method on a remote object almost as if the object were available locally. This makes distributed object-oriented applications easier to develop. Let us understand how RMI works. The process begins at the server side. First, the server creates a remote object. Then the server registers this object with the RMI registry. The RMI registry acts like a directory. The client can use the name of the remote object to find the object through this registry. Once the client obtains the reference, it can invoke the required method. The communication flow shown in this slide is client, stub, network, skeleton, remote object, and the result travels back through the reverse path. Now let us look at the Java example. First we have a remote interface. The interface is named hello. It contains a method called say hello. This method throws a remote exception because communication across a network can encounter remote communication problems. Next we have the server implementation. The class is hello IMPL. It extends unicast remote object and implements the hello interface. The say hello method returns hello from RMI server. Finally, we have a client program. The client uses naming.lookup to find the remote object using its name. The example name is hello server. Once the remote object is obtained, the client calls obj.sayhello. The result returned from the remote server is then displayed by the client. So this example demonstrates how Java RMI allows a client to invoke a method on a remote object. So let us quickly summarize what we have learned in this session. We started with the concept of client-server system. A client requests a service and server provides the service. Then we studied four important communication mechanisms. First is sockets. Socket provide communication endpoints using IP addresses and port numbers. Second, remote procedure calls or RPC. RPC allows a client procedure to invoke a procedure that executes on a remote server. Third, pipes. Pipes provides a stream-based mechanism for communication between processes. We discussed ordinary pipes and named pipes, and finally, remote method invocation or RMI. RMI allows Java objects running in different JVMs to communicate and invoke remote methods. So the key concepts to remember are sockets, RPC, pipes, RMI. These mechanisms are fundamental to communication between processes in distributed and network systems. Thank you for watching. See you in the next session. Thank you.